I will be doing assessment video number 5C. So, the helicopter above is carrying cargo and flying horizontally. The helicopter and the cargo is accelerating forward with 3 meters per second squared. What is the angle theta between the rope and the vertical? And what is the tension in the rope? So we have this helicopter that is accelerating in the horizontal direction at 3 meters per second squared and is carrying this cargo, which has a mass of 30 kilograms. And this prompt is asking us to find the tension between the vertical and the rope. So that's that, theta. And it's also asking us to find the tension itself of the rope that the helicopter is using to hold the cargo. Okay, so let's start off by finding the tension first. To do that, we can split the tension into x and y components. The x component of tension is t sine of theta, because opposite over hypotenuse is sine of theta. So that would be t sine of theta in the x component of tension. For the y component, it will be cosine of theta, because cosine is adjacent over hypotenuse. So the y component of tension will be t cosine of theta. Okay, to do a free body diagram of the cargo, we would know that in the x direction, the only forces acting on the cargo is the tension, the x component of the tension, which is t sine of theta, what we already found out. And in the y direction, we know that the only forces acting on this cargo is the force of gravity pointing downward and the force of tension in the y direction, or the y component of the force of tension, which is t cosine of theta, as we established before. So we can use F equals ma, the equation, Newton's second law, which we have been learning in class, to solve for each component of tension. So what we do is we can do the y component of tension, which would be t cosine theta minus fg. And so it says 0, it's equivalent to 0, so ma is equivalent to 0 because there is no acceleration in the y direction, because this cargo is not in free fall. This cargo is staying at the same altitude or height as the helicopter is not changing in height. And since the object is not in free fall, the acceleration is not 9.8 meters per second squared. It is actually 0. So you would do Fty, the force of tension in the y direction, minus the force of gravity, is equivalent to 0. In the x direction, since the only force is the x component of tension, that would be force of tension x component is equivalent to mass times acceleration. So we plug in values to get t cosine theta minus the force of gravity, which is the weight, which would just be the mass, which is 30 times the value of g, which is 9.81, and that's equivalent to 0. In the x direction, that would be t sine of theta is equivalent to the mass again times the acceleration in the horizontal direction, which was given to us, which is 3 meters per second squared. And so you would get those values and you would calculate them to get the tension of times cosine of theta in the y direction is equivalent to 294.3 newtons, and the tension times sine of theta in the x direction equivalent to 90 newtons. So this is 294.3 and this is 90. So what we need to do to find the tension of this rope is use the Pythagorean theorem, which is a squared plus b squared equivalent to c squared. So that's c squared. So we can just do the square root of the x and y components squared. So the square root of 90 squared plus 294.3 squared is equivalent to the tension, which is 307.75 newtons. And using this information, we can also find the angle theta, which is just because we found out what the sine and cosine is. We found the x and y components of tension. We can just use tan of theta, which is sine over cosine. So tan of theta, we found out that tan of theta is equivalent to 90, which is sine, over sine, or the x component of tension, over 294.3, which is the y component of tension, cosine. And if we do the inverse tan of that value, of the inverse tan of 90 over 294.3, we would get the angle, which is 17 degrees. So we found out the theta between the rope and the vertical is 17 degrees, and the magnitude of the tension of this rope is 307.75 newtons. And this relates to what we've been learning in class, as this involves Newton's second law. And that's it. Thank you.